Hi everyone, welcome to our video on the properties of definite integrals. So a lot of these properties we've already been using, like number 3 here that's highlighted, but some of the other ones, well, wait, but number 3 we've kind of been using where we do it term by term. So this video kind of shows it just in the red, or this part where we did it term by term. Okay, so that's been normal. And the constant rule, well, we certainly can have, we could have used at any point here, so that's nothing new. And then these other ones are, so number 5 lets us split up if we need to. So it just lets us know. So let's just draw a quick sketch to show what that means. So if I had some curve, and here's A, and here's B, well, if I find some midpoint and I still find that area and I add that area, so that's saying this first area plus this second area equals the whole area. So that's all that one means, is if you split it up, it still matches. And the first one, just to show what that one means, it's saying, well, if I have a curve, but if I don't go anywhere, because it's A to A, then I don't have any area to fill in. So that's why that one's 0. And then one last one, this is notice where the bounds have changed. They got flipped. So A was below, but now it's above. All we have to do is just throw a negative in front, and it would match. Okay, so this is going in order, from smallest to biggest. We're assuming A is smaller than B, so smallest to biggest. This one switched the order, so that means we throw a negative in to make sure it will match. Okay, anyway, so that's some properties. What's good about these properties is they're pretty straightforward, and they're often pretty easy to work with. Okay, so let's do this question here. So suppose we have these 3 integrals where they give us the answer to them. So this first one is equals 10, the second one equals 6, the third one equals -2. We're going to use the properties to evaluate these following. Okay, well, this first one is just a switch on the bounds. So this is the same thing as 2 to 7, but just put a negative in front. Okay, notice our bounds got switched. So the one below is now above. And that means just make sure to put in that negative right there. Okay, and then that's going to be pretty much it. So I just have to make sure the negative's still there. And then I have this in the first setup. It's right there. It equals 10. So, but just negative in front means it's now -10. Okay, so sweet. So these properties, again, make it pretty fast. Okay, and let's do number 2, where we have the integral from 5 to 7 of this expression. Well, it is the same thing as, I'm going to do it in multiple steps. So it's 5 to 7 of 2f of x dx plus the other integral of 5 to 7, 6g of x dx. So this is just splitting it up using the 1 rule. And then I'm going to use my coefficient rule. So I'm going to take the 2 out. So it's from 5 to 7, and we have f of x dx. Plus, let's take the 6 out, from 5 to 7, g of x dx. Okay, and then these we have, this whole thing, we have, it's this right here. Okay, so it's 6. Okay, so we're just going to replace this whole big bracket thing with just 6. And then 2's still hanging out front there. And then we still have plus that 6. And then this one we have as well. Let's put it in red. This one we have as well. It's just in our description here. From 5 to 7 they say that's -2. Okay, so let's just put in -2 right here in this bracket. Okay, and that's what that's equal to. And then now it's just order of operations. 2 times 6 is 12. 6 times -2 is -12. This happens to equal out to 0. Okay, so that's it. Okay, so that's how we can use these properties. So again, these properties are real nice. We've been using some of them. And when they're abstract like this, I think they're the best types of problems we could have because they're usually faster. Okay, so let's do one other where they give us a picture. And they tell us the figure shows 4 regions bounded by the graphs of y equals f of x. A1, A2, A3, and A4 have areas 1, 4, 2.5, and 0.8 respectively. Use this information to evaluate the following integrals. Okay, so they gave us the areas. So remember, regular old areas they're considering as positive. Okay, whereas integrals, we have to know that it represents a net area. Okay, so this one right here is the net area from x equals 0 to x equals c. So that's the net area. So what this becomes, let's go ahead and write it, from 0 to c of f of x dx is equal to, all right, so we have area 1 is below the x-axis. So area 1, I'm going to write it as area 1 plus, but we'll mark it in a certain way, plus area 2 plus area 3. So that goes from 0 to c. So I have my 3 regions that are from 0 to c. But area 1 and area 3 should be negative because they're below the x-axis. So both of those are below the x-axis, so that means they really are negative areas when viewed as net areas. So let's just say negative, instead of areas, let's say negative net areas. Okay, so that word net is very important to us. Remember, net means we look at positives and negatives. And the integral is doing net area. Okay, so that's automatically doing the net area. Okay, whereas the A2 is going to stay positive. So what we're going to do to rewrite this, so our area 1 says it has an area of 1. So area 1 says it has an area of 1, but it's below the x-axis, so we should really just make it negative. So that's all we have to do there. And then plus, area 2 is automatically positive no matter what because it's above the x-axis. And they say that one is 4. So area 2 is 4, so we'll do plus 4. And then our last one, we have plus the third area. They said is 2.5. So, because again, it's below the x-axis. So, but all we'll do is just make sure it stays negative, or we'll change it to a negative because we want net area, not regular area. Okay, so again, kind of confusing. That word nets is very important. The integral is always doing nets area. Okay, and then now we can add this up. It looks like it would be 0.5 as a final answer. Okay, so that's the net area. So all that means is from 0 to c, there's just a tad bit more area above the x-axis than below. Okay, and then in number 2, we have an absolute value. Okay, so the absolute value is now just mentioning area only. Oops, let's spell area, right? Area. So that would mean it's not net area anymore. So that means all areas are now back to being positive. All areas are considered positive. Okay, so on this, our setup from a to c of the absolute value of f of x dx is equal to, okay, so let's see. So here's a, and then it goes to c. So it's just these two areas. It's a2 plus a3. But this time around, again, they're automatically going to be positive. Do not change them into negatives, or change the one that's below the x-axis into negative. So area 2 is automatically above the x-axis anyway. And we just have to look back at our information. Area 2, they said, is 4. Okay, so area 2 is 4. And then we have plus area 3. I'm going to put it in green. Area 3, whoops, there, freaked out. Area 3 is above the, or is below the x-axis. There's area 3. So net area, it would be negative, but just area, it's now positive. So area 3, in the information they say is 2.5. So we would have 4 plus 2.5. All right, and then now we could just add those, and it's done, 6.5. Okay, so there we go. Okay, so that's a difference. So absolute values. So the absolute values means area. Let's put that one more time. Absolute value equals area. Yep, let me try this one. And then, but that's our main difference. And with pictures like these, just use your rules. Just kind of break it up and set your areas up like this with the sums, A1, A2, A3, so forth. And just again, consider which ones might become negative, or if they should remain positive, just depending on the situation. Okay, so but that's it. Thank you for watching. If you have any questions, let me know, and I'll see you next time.